Good afternoon, everyone. My name is Abass Okeola. I'm a PhD candidate at the Department of Civil and Environmental Engineering, University of Delaware. And in conjunction with my colleague here, Saber Larfi, we'll be talking to you about the bonding of polyester polymer concrete to ultra performance concrete. So I'll be talking to you about the introduction, the objectives of our research, the current guidelines and specifications, as well as the methodology, while my colleague Saber will talk to you about the results and the conclusion. So we've heard a lot about ultra performance concrete today, and I'll be focusing more about link slab, which is what UHPC is mostly used for in Delaware, because this is a Delaware Department of Transportation funded project. In applications such as link slabs, where UHPC is used to connect slabs, overlay materials that are used on UHPC also extend to the connections where we have ultra performance concrete. Common overlay materials used in Delaware are polyester polymer concrete, latex modified concrete, and modified type D concrete. In this research, we'll be focusing on polyester polymer concrete. And when we have polyester polymer concrete bonded to UHPC, the bond performance of PPC to ultra performance concrete is not known. Bond performance of other materials has been extensively studied in literature. So the objective of this research is one, we need to know the sensitivity of pull-off bond test to parameters such as coring depth, overlay age, and surface preparation. What ASTM recommend, ASTM 1583, is a minimum core depth of 0.5 inches beyond the interface of polyester polymer concrete to ultra performance concrete. But this recommendation is for normal concrete, not for ultra performance concrete. There is also no guidelines for overlay age as regards surface preparation for ultra performance concrete, among other parameters. Secondly, surface roughness measurements that are used are mostly for normal concrete. There is no guidelines for estimating the surface roughness of ultra performance concrete. So what we have in terms of current guidelines is one, a minimum bond strength of 250 PSI is recommended by AASHTO T-34 and ACI 548 when you have overlays on normal concrete. We also have a recommendation of overlay having a minimum compressive strength of 5 KSI. And Delaware Department of Recommendation requires that ultra performance concrete should have at least 10 KSI before you prepare the surface and apply your overlay material. So bearing this in mind, we prepared our test specimen to have a slab base, just to have some level of robustness in our specimen. We have nominal reinforcement in there to control thermal shrinkage. And on top of that, we have our ultra performance concrete, which is 3-inch deep. On top of that, we applied our PPC material, which was 1-inch deep. We partitioned the slab to allow us to have areas where we can put our drill bits such that we can drill on either side of the slab. Each core has a diameter of 2 inches. And this is as recommended by ASTM 1583. So to prepare each of these surfaces, we adopted 3 surface preparation methods. The first one is the use of a surface retarder, whereby after pouring the UHPC, we applied a light layer of surface retarder to delay the curing of UHPC, which was later washed off to expose the fibers. Then we also have hydrodemolition, whereby we pressure wash the UHPC surface after ensuring that it has reached the minimum 10 KSI recommended by Delaware Department of Transportation. And thirdly, we adopted grinding using a hand grinder and sandblasting to prepare the surface. For each of these surface preparation methods, we tried to use 3 approaches to quantify the surface profile. The first one is the use of the ICRI CSP chip, which is pretty much a quantitative approach whereby you look at the surface of the chip and you try to mimic what the surface of the UHPC look like, and based on that, you assign a number to the surface profile. Secondly, we use a surface profile gauge, which is more of a quantitative approach that gives a number to the surface profile of the prepared UHPC slab. And the third approach we used was a sand patch method, whereby you have glass bead that you spread on your UHPC surface, and based on the diameter and the amount of glass bead that goes into the pores, you can estimate the surface roughness. To conduct the test, we use metallic pork that looks like this, and you have epoxy adhesive glued on top of the surface, and you attach that to the surface of your polyester polymer concrete. Then we use a process pull-off tester to apply a tensile force of 5 psi per second. Since we are measuring bond performance, we can evaluate our bond performance in terms of bond strength and failure mode. When conducting this test, 4 failure modes are possible. The first one is failure in the UHPC. You can also have failure in the PPC. You can have failure at the interface of UHPC to PPC, and you can have failure of the metallic pork. Failure of the metallic pork does not really tell us anything. It just shows that the adhesive used was not properly glued to the surface. Failure of the PPC to UHPC is telling us that the surface preparation method that we used was inadequate. So these 2 failure modes are the most desired failure modes, as they indicate adequate surface preparation. So Saber here will take us through the results and the conclusion from this study.
Thank you, Abass. So after preparing the surface, the different roughness measurement, the different roughness from different methods was measured with the either ACRI chips or the sand patching or the profile gauge. As you see, the surface that was not prepared looks smooth, and the average roughness with the sand patching gave a result of 0.7 millimeters, while the results from the profile gauge shows that 80% of that surface approximately have a roughness below 1 millimeter. Now, moving forward to the grinding and sandblasting, it clearly looks more rough than the no preparation, with an average result of the sand patch of 1.2 millimeters approximately. And the graph on the empirical cumulative probability of the profile gauge results shows more roughness because the graph is more inclined towards the right. And with the last 2 methods, the surface retarder and the hydrodemolition, they are comparable in terms of exposing the fibers. And it's worth mentioning that those fibers are exposed to corrode over time, and especially that we left our specimens to cure for at least 28 days to limit the effect of the autogenous shrinkage. It's also worth mentioning that the fibers in the hydrodemolition are weaker because of the high pressure water that was used, that was approximately 34 KSI in this case. These 2 methods are comparable in terms of exposing the fibers, and also that hindered using the method of sand patching because of that. You may notice that I haven't mentioned any results from the ICRI chips, and that's because the UHPC is different than normal concrete in its nature. And what I mean by that is that UHPC doesn't have aggregates, and some of these methods either expose the fibers or open up some bubbles, which is different than normal concrete that the ICRI chips are made for. So before continuing our tests on the surface prep methods, we needed to decide both the coring depth and the overlay age. Starting by the coring depth, what I mean by that is how deep we go into UHPC, as this illustration shows. So we tested different coring depth varying from 0 to 1.5 inches. And we noticed a decrease in bond strength from approximately 820 PSI for the 0 inches to approximately 610 PSI for the 1.5 inches. This decrease in strength is explainable by the increase in probability of having a weaker point in our material the longer our core is. And we can also see that all the results are above the AASHTO requirement, which is a good sign. So since we needed to decide which coring depth to adopt here, we wanted the core depth that shows more failures at the interface, because that's what we are testing. And the failure mode distribution shows here that the 0.5 inches have more failure modes at the interface. There is another point here, which is that the clear cover in the field is approximately 1 to 1.5 inches. Is between that, and we didn't want to run into the reinforcement when we are conducting our test in the field. So we finally chose the 0.5 inches of coring depth. So the second thing here is the overlay age. Since polyester polymer concrete is a fast curing material, we weren't expecting a high variation between the overlay ages. And that's what we notice from the 14, 28, and the 56 ages, with an average between 720 and 700, maybe, or 760 PSI. However, the 7 days age is lower than that, approximately 630 PSI. And that was from a different batch of UHPC than the other experiments. And that probably was the cause here. So a good thing we see is that all the experiments of the overlay age are way above the AASHTO requirement, and that's a good thing. And we could adopt any of these ages. However, we went forward with the 14 days because it allowed enough time in the lab to prepare our specimens, especially that we are conducting a lot of tests at the same time and also coring. And that's what he mentioned before, that's not an easy task anyway. So now the results with the surface preparation. If you remember from the roughness measurements, the surface that was not prepared looks smooth, and we can see the result here. The average failure strength was even below the AASHTO requirement, which is 250 psi, with only few results that are around 300 and 400 psi. And those were from the edges of our strip, where UHPC cured in a way that had some wrinkles with the way that we poured it in. With all the other methods, we see that they have good bond strength, and the average is decreasing from 700 approximately to 650 psi from all the methods. And this decrease in strength is probably also to the different batch of UHPC for all these experiments. It's we can see that we can see that the bond strength for the hydrodemolition is lower, and that could be due to having the high pressure water that was used in this method, probably weakening the specimens. So it's true that the hydrodemolition and surface retarder have lower strength compared to the grinding and sandblasting. However, in terms of failure mode, we see fewer interfacial failures for these two methods specifically. However, and also for the interface failure mode, all the failures were recorded at the interface, most of them being totally failure at the interface, and those that were between 300 and 400 psi were mixed failure modes. However, the majority of the surface was failure at the interface. We can also see here that the fibers exposed for both the hydrodemolition and surface retarder contributed to the interface by being embedded into PPC that we see here, fibers, which is an interesting thing to see. And we can probably see that only the fibers that were in the direction of the core that contributed into this, and still it's a good thing to see. As a conclusion, we can say that no surface preparation resulted in bond strength below the AASHTO recommendation of 250 psi, while the other methods proved to improve the strength to at least 2 times that value. We can also say that the age of PPC overlay, 7 days or older, has no effect on the bond performance. And finally, we can say that using the interface profile gauge is the most appropriate method for the roughness measurement due to having difficulties of using the other two. Moving forward, we'll be conducting field evaluations on bridges that have PPC as an overlay, and we'll also test different overlays such as the modified type D concrete and the latex modified concrete to compare with polyester polymer concrete. I would also take the opportunity to express our gratitude to the following professionals that contributed to the progress of our research, and to Delaware Department of Transportation for their funding to this project. Thank you so much.
Thank you, Saber and Abass. Do we have any questions in the room? And while we're waiting for them, could David? So I guess I have a question here. Does it really matter what mode of failure you got when your bond strength was so much higher than the minimum from AASHTO? I mean,
so we were testing the bond strength, and since for all the methods, the bond strength, or actually the failure was recorded higher than the requirement of AASHTO, it wasn't so much important, but we still wanted to see when it fails, what's the limit. So when it failed either UHPC or PPC, it means the interface is even stronger than those two parts, or the one that failed more specifically. When we chose the failure at the interface core in depth, we wanted to move forward with that to test the interface the most than the other two regions. Yes. And probably for the other overlays, if we experienced more failures at the interface, that would express the bond more. For the case of polyester polymer concrete, they were all great, and the bond strength was well. So
yeah, I guess we'll just have to wait in time to see how these overlays perform and somehow correlate that back. If okay, well, round of applause for all our presenters today. Thank you.